Buddy, my name is Mohammed Ablahay, and I'm gonna be discussing polycarbonate, an important engineering plastic known for its strength, clarity, and versatility. I'll explain how polycarbonate is manufactured and formed, walk you through specific production processes, and show you finished products using these methods. What is polycarbonate? Polycarbonate is a thermoplastic polymer, meaning it softens when heated and solidifies when cooled. It's widely used because it combines high impact resistant, lightweight, and optical clarity. You've seen it in things like eyeglass lenses, safety goggles, and car headlight housing. Thermoplastic behavior, it can be melted and reshaped multiple times without significant degradation. Impact resistant, which is much stronger than glass or acrylic, making it ideal for protective gear. And it's also lightweight, about half the weight of glass, reducing strain in applications like light eyewear or automotive parts. And it's heat resistant, maintaining stability up to negative 135 Celsius using an electronics and lighting. Optical clarity, which is nearly as transparent as glass, which is why it's used in lenses and windows. The manufacturing processes, polymer refining slash raw materials production. Polycarbonate typically comes from reacting PBA, bisphenol, with phonogen. This chemical process produces long polymer chains which are cooled and cut into pellets. These pellets are the feedstock used in forming processes. Interfacial polymerization. PBA salt dissolves in water reacts with phonoxide and methylene chloride, forming polycarbonate at the interface of two inscalable liquids. Pellet formation, extrusion, cooling, and pelletizing. Injection molding. Injection molding is the most common method of forming polycarbonate into usable parts. The steps are pellets are fed into a heated barrel. A screw rotates, melting and mixing the plastics. Melted polycarbonate is injected under pressure into a mold cavity. The mold is cooled and the part solidifies. Yeah. These finished parts is ejected, and why it works well with that's why it works well with PC. Great for making clear complex geometrics, high dimensional accuracy, and fast production cycles. Extrusion and secondary processes. Extrusion is used when we want like continuous shapes like sheet rods or tubes. The steps are melting polycarbonate is pushed through a die. It emerges as a continuous sheet or profile, and it cools, trimmed, and cut to length. The secondary process of the polycarbonate parts often undergo finish to improve durability. The common finishing steps are hard coat application, which improves scratch resistant, UV blocking coating, prevents yellowing, CNC machining for tight tolerances, and polishing for optical clarity. And these are some finished products, which are CDs, DVDs, and Blu-ray discs, electrical housing and connectors, and transparent roofing / greenhouse panels. Conclusion is, in summary, polycarbonate is a versatile, high-performance plastic used across the automotive, electronics, and safety and construction industries. Its properties allow it to be easily molded or extruded into clear, durable shapes throughout processes like injection, molding, extrusion, and finishing. And these are my references. Thank you.